Aloha class, section 6.4, exponential growth in today and decay. Today I'm wearing my pink. I got my little button on. Some bonus points whenever you wear pink and you're showing the support for the fight against breast cancer or cancer in general. You know, unfortunately, if you're a junior or senior in high school, you're watching this video, your life has probably been affected by cancer in some way, shape, or form. I know my father passed away from pancreatic cancer about 10 years ago. Still kills me to this day. Kills my heart inside that he's no longer with us. So my thoughts and prayers are with you, your family, or anybody in your family or yourself or whatever it may be that has been affected by such a gross disease. But wear your pink and get some bonus points in class showing your support. All right, here we go. Exponential growth and decay and how we use that in AP Calc. It's topic 7-8, exponential models with differential equations. It's also using, and I forgot to put this one up a couple videos ago, of 7-7, where we're finding particular solutions using initial conditions and separating and integrating some problems, okay? So let's get after it. This is usually almost guaranteed to be an AP topic. And it's usually a free response. So this is big time. So really make sure you're focused here throughout this lesson, okay? Here we go. A rate of change of a variable y. Hopefully you're like, oh, that means derivative. And it's the rate of change of our variable y. And it says y is a function of time t. So rate of change means derivative with respect to t. Why? Because it's a function of not x, but of t. And it says is proportional. That goes back to this links kind of calculus with algebra 2. And that is equal to, because is means equal in math, proportional means k times. Remember, you also had something called inverse proportional. That would be 1 over k. Okay, but proportional kind of means directly proportional. That's why we do k times y. So you need to know that. Just by reading that right there, you should be able to write that down, okay? Example 1, find the solution to this differential equation. So there we go. There's our differential equation. I'm going to find the solution to this guy given an initial condition. So they give me that as my initial condition when time equals 0. Oh, snap. And you want to know how to do this yourself. This is almost guaranteed to be a free response question. Obviously, a little bit more difficult than this guy right here. But let's see if we're able to do it, right? How do we do this problem? Remember, we have 2 steps. First step, separate, right? And I have t's and I have y's. So I'm going to get all my y's on one side. So I'm going to divide that y over here. And on this side over here, I'm going to just multiply by the dt. And then I'm going to take the antiderivative of both sides, right, class? So we go a little antiderivative, a little antiderivative. The antiderivative of 1 over y is the natural log of the absolute value of y plus c, right, class, is equal to, well, now k is a constant. So it'd be like the number 5. And the antiderivative of 5 would be 5x, in this case 5t, right, because it's with respect to t. So this would be kt plus c. Right, class? All right, let's go ahead and finish this guy. I've got to solve for y. So I'm going to write this as log base e to the absolute value of y is equal to kt plus c. All right, and then I'm going to go ahead and do my little, change my log to an exponential. So that'd be the absolute value of y is equal to e to the kt plus c. And that would be equal to y equals plus or minus e to the kt plus c. Right, would be equal to plus or minus e to the kt times e to the c. And e to the c is simply a constant. So I could write this as plus or minus c e to the kt. And that's what y would be equal to. Everyone with me? And that'd be solving the differential equation. Now, some people could say it'd be plus or minus a constant, right? We could go a step further. Plus or minus a constant would still just be a constant. So for the purposes of this problem, right, it's very general, it's very basic. We're going to write it as y equals c e to the kt power. And what you want to know is if you ever hear this, you could skip right to that. Okay, if you can acknowledge that this will end up giving me that as a particular equation. Now, they give me an initial value. And they say to y equals y sub 0. That just means you're going to plug a 0 in for t. And let's go ahead and plug a 0 in for t. And it'd be k times 0, which is 0. E to the 0 is 1. So they're saying that y sub 0 is equal to c. So if I want to get real particular, the best equation for this is y equals, instead of c, I'm going to put y sub 0. It just means the initial value of y. So whatever you start off, it's your value of y is equal to e to the kt. And that's the one you want to remember, that these two dudes are linked. And if you can remember it, you don't even have to show me any work. Test, quiz, whatever, AP exam, don't even have to show me any work. You can go from there to there. You don't even have to go through the separating of variables and all of that work. All right, exponential growth and decay. What do you notice? That when they give you this and they give you that, it means that, right? We just kind of went through that. Now, how do we use this stuff in problems to make it easier for us? This is how. Okay, example 2. Rate of change of y. And it's with respect to time because we got all that time right there. So rate of change of y would mean this is proportional to y. Oh, snap, right? Oh, snap. Where's Homie Holmes? Oh, no. Oh, Homie Holmes is way over there. He's chilling, trying to eat some candy. All right? So if I know that that means this, I can use it. Okay? If I don't know that this means this, I got to go and separate my variables. No, thank you. Okay? So instead I go over here and let's do this problem. Well, they give me this initial condition. And they say y equals 2 when time equals 0. So that means y sub 0 equals 2. You're going to say, Mr. Tanaka, couldn't I have skipped that step? You sure could have. If you knew that that was your initial condition, you could have just came here and said y sub 0 means the initial amount, and you could have just went there. And this makes a very difficult problem very okay. And they just ask, hey, when t equals 2 and y equals 4, what's the value what's the value of y when t equals 3? Well, here, let's just keep on using some of these conditions that they gave me. And what am I trying to do now? Here, I'll break it off right there. Y equals 2. I'm using the 2 from that spot right there, right? And it's E, and okay, that'd be 2K, because K times 2 is 2K. Now let's do some math. Let's divide by 2 right there. 4 divided by 2 is 2. I get E to the, and what I'm trying to do here is I'm trying to solve for K, because then they're going to ask me to find a value of Y. So let's keep on rolling. I think I might need a little bit of room here. So let's move that up a little bit. Sweet, I got a ton of room to work with. And if I solve for K here, let's see, what would we do here? We change it to a log, right? Let's change it to a log, and that would be log base E of 2 equals 2K. If you didn't know that, you better brush up on your log skills. That means K is equal to the natural log of 2 over 2. All right, so let's rewrite my problem. Y equals, the initial value was 2, right? We got that from that piece right there, is equal to E. I had to find K. How did I find K? By using that right there, and K is the natural log of 2 over 2. T. There is my problem. And then now I can answer it and get a 100 on the AP exam, because all they want me to do is plug a 3. So Y of 3 is equal to 2E to the natural log of 2 over 2 times tree. This would be a calculator, dude. And if you plug all of that stuff into your calculator, you get an answer of 5 points. Should we truncate or should we round? Remember, you can round or truncate to 3 decimal spots. So 5.657. Once again, this turns into such a long problem if you do not know that that means that. Okay, so make sure you got that down. Make sure you practice these guys. Oh, sweet. Example 3. Prime example of the type of question that comes up on your AP exam. All right, so really make sure you're focused throughout this entire next problem. All right, here we go. Newton's law of cooling. Newton's law of cooling states that the rate of change in the temperature of an object is proportional. Oh, so this is kind of bringing up, right, that problem that we just did. It says the rate of change of temperature. So what would that be? D, I'm going to use a capital T, right, to stand for the temperature. So the rate of change means derivative, and it's going to be with respect to time. So that'd be a lowercase t. Of an object is, right? Is in math means equals. Proportional. Proportional means K. To the difference, okay, it's proportional, so it'd be times something. So it's going to be times the difference of two things, okay. So the difference between the object's temperature and the temperature in the surrounding medium. What the what? Okay, so we have the object's temperature and change into, okay, so the object's temperature, we'll call that T. And then we have the temperature also of the room. It's the difference between those two things. Hopefully they give me some information. If not, that looks way too tough to deal with. A detective finds a murder victim at 9 a.m. Oh no. The temperature of the body is measured at 90.3. 1 hour later, so initially when time equals 0, the temperature of the body, right, was 90.3. And then it says at time equals 1 after, my temperature of the body is 89 degrees. So it's important to write stuff down as you read it. The temperature of the room has been maintained at a constant 68 degrees. So, temperature of the room, right? They said that earlier. Sweet. So I can simplify this a little bit, my differential equation. Why is it a differential equation? Because it's got a derivative and it's an equation. Proportional to the temperature minus the temperature in the room. So I'm going to put that as 68. Okay, part B. Big time AP question right here. Solve the differential equation and estimate the time the murder occurred. Woo! Seems a lot in there, but you're going to get 5 to 6 points if you can just do the separate and integrate correct. All right, so let's see if we can do it. Let's use this guy here. We get dt, that's the temperature of the body, all over dt with respect to time, times k, the difference of the temperature of the body with the temperature in the room. All right, how do I do this bad boy? Well, we separate, right? So I'm going to separate, so that becomes 1 over t minus 68 dt is equal to, d capital T. That's a big time importance, right? Because we're separating the capital T with the lowercase t. And there we go. Kind of similar to what we did earlier, right, class? All right, this is 1 over something. And the antiderivative of 1 over something is the natural log of that something. Now, you should use u sub. However, if I take the derivative of that, it's just going to be 1. Right? That'd be like x minus 68, right? The derivative of that is 1. So a capital T minus 68, if I'm finding the derivative with respect to d capital T, would be 1. And remember, you don't really need u sub if your derivative of the inside is 1. Just make sure you keep that inside as the inside, right? Is equal to kt plus c. Now they gave me an initial condition, right? What did they give us? They gave us that the body's temperature was 90.3 when the time was 0. Okay, so let's use that, right? Let's use that, class. So we have the natural log of the body of the temperature, which, all right, so that initial condition of t equals 0, body is 90.3, so we got 90.3 minus 68 is equal to k times 0 plus c. That means c is equal to the natural log of the absolute value of 22.3. The absolute value is 22.3, so we can plug that in now. Let's go ahead and use that c and plug it in back over here. So we have the natural log of the absolute value of t minus 68 is equal to kt plus the natural log of 22.3. Let's solve this bad boy. We got to get t by itself there. So we change it from a logarithmic to an exponential. So it would be t minus 68 equals e to the kt plus the natural log of 22.3. Now I'm going to clean this up right here, right? So I get the absolute value of t minus 68 is equal to e to the kt times e to the natural log of 22.3. Remember, I said you've got to be so good at your log rules, right, class? So good at it. So I'm going to still simplify this bad boy is equal to that. E, that's log base e, so that's just 22.3, and then e to the kt. And then I got to get rid of my absolute values. And how do I get rid of that? It's plus or minus. Okay? And then we add that 68 on both sides. And there is my differential equation. Boom. Remember, I got to pick the plus or the minus, and I can do that by using my initial condition. And what was it? They said if I put a 0 in there for t, I've got to get 90.3. So that means we're going to get rid of that. It's got to be the plus case. So here we go. Let's turn this guy blue because this problem's so fun. We're kind of trying to solve a murder here. So we got the body temperature is equal to 68 plus 22.3 e to the kt. And if you notice, I actually can't use that because I still don't know what k is. So if I don't know what k is, what do I need to do? Well, they gave me another condition earlier. They said 1 hour after, what was the temperature? I'm looking in my notes right here. It's 89 degrees. So guess what? We're going to put an 89 in there. And this is going to allow me to find out what the heck K is. And I'm going to put a 1 in for K. 1 in for T, I'm sorry. Solve that bad boy. Let's make sure you guys all remember to solve that. We subtract the 68. If I subtract the 68, I get 21. And then I'm going to, I guess I won't do two things at once just so I don't lose anybody. You're going to divide by that 22-point tree, right? And then, hey, I gotta find K. And whenever I have to find K, what do? I change it from an exponential to a logarithmic. So that guy is going to change to log base E of 21 over 22.3, right, class, is equal to K. There we go. Oh, snap. So we get this cool, sweet equation, which is capital T equals 68 plus 22.3, right? We're going to go E raised to the, oh my gosh, it's natural log of 21 over 22.3 T. Boom. There is my sweet, fancy equation, right, class? And then what's the question asking us? Oh my gosh, what are we even trying to figure out? It says 1 hour later. All right, so let's go black. It's asking us, when the heck did the murder occur? How am I supposed to figure that out? Oh boy. All right, so we got this cool equation. How could I figure that out? I'm going to do my work in black now. This problem just gets more and more fun, and we're going to get it done in under 20. Okay, so what's the temperature of somebody? You know, just normal. Let's say it's normal temperature. Okay, if I looked it up in Google, it's 98.6. So guess what? I'm going to put a 98.6 in there, right? So before they died, that would be their temperature. And then I'm going to put all this in here. And then what I want you to do is hit that pause button, and can you solve for that time? Okay, hit that pause button. All right, I'll do it with you. Hopefully you tried it on their own. I'm going to subtract that 68. And I get 30.2 is equal to 22.3 e to the natural log of 21 over 22.3 t. Divide by that. Oh my gosh, I even need more space. Oh no, it didn't go up. Then let's roll. That'd be 30.2 over 22.3 is equal to e to the natural log of 21 over 22.3 t. Oh, and then that's an exponent. Or hey, could I maybe simplify a little bit? Right? I sure could. All right, here we go, class. How do we finish this bad boy out? Yes, I know that should be a 6. I just caught it. So let's take the natural log of both sides, and we get the natural log of 30.6 over 22.3 equals the natural log of e raised to the natural log of 21 over 22.3 t. When I have that, it kind of gets rid of it. So we get the natural log of 30.6 over 22.3 is equal to the natural log of 21 over 22.3 t. If you divide this guy on both sides, you get an answer of t equals negative 5 point. I got the answer over here. What is it? Negative 5.268. 268. So that means 5 hours ago and some change, right? I could multiply that right there by 60, right, to get how many minutes? And I've got an answer of 5 hours and 16 minutes ago, which puts us at 3:44 a.m. See if you can figure out how we got that answer. I got to get to math lab. So under 20, good to go. We got a test coming up soon. Study hard. Work on those worksheets. Aloha.